Hey guys, Ms. Gosling here. In this video, you're going to learn about centripetal force. By the end of the video, you'll be able to solve centripetal force problems. So let's go ahead and get started. So I'm going to start with the simple equation for centripetal force, which is that centripetal force is equal to mass times velocity squared divided by the radius of our circle. So let's go ahead. I'm going to just draw that out here really quickly. If we are moving on a circular path, the force required, which is going to be pointing towards the center of our circle, since that's kind of the direction of our acceleration, is equal to the mass of the object moving on the path times its linear speed, v, times the radius of the circle. Now, you can probably see, if you remember the equation for centripetal acceleration, where our centripetal force equation comes from. So remember, our centripetal acceleration is given by v squared over r, and force is always equal to mass times acceleration. So our centripetal force is equal to mass times our centripetal acceleration, or mv squared over r. Now, one thing I do want to mention is a common misconception about centripetal forces. The name of the force acting on an object is never centripetal force. Again, the actual force acting on an object is never the centripetal force. Rather, the actual force acting on an object, so tension or gravity or something like that, is acting as a centripetal force. So what that means is if I have a little ball on a string, and I'm swinging my ball around in a circular path, the centripetal force is, so the force keeping my ball moving on that path is tension, right? It's that tension in that string. And that tension force is acting as a centripetal force. So I can use the centripetal force equation to find my tension because, again, my tension is my centripetal force. But the actual force that's causing the object to keep moving in the circle is tension. Similarly, we have our Earth, and we have the moon going around the Earth. And again, that moon is in circular motion, so it's feeling a centripetal force. But in the case of the moon, that centripetal force is the force of gravity, because that's the actual force that's keeping it moving on its circular path. So gravity in this situation is the centripetal force. So the ramifications from this is basically just, I don't want to see you just draw FC on a free body diagram. So if you are drawing the free body diagram for an object in circular motion, the actual force, so gravity or tension or electricity or magnetism or whatever that force is that's actually keeping the object on a circular path, should be the force that you draw on your free body diagram versus just drawing FC. Because again, centripetal force is not a physical force. It's a description for a category of, or it's a description for any force that keeps an object moving on a circular path. So with that misconception and warning, let's go ahead and talk about some examples. So example 1, I swing my headphones, which have a mass of 5 grams, around my head at a speed of 10 meters per second. If the length of my headphone string is 0.5 meters, what is the tension in the string? So drawing a free body diagram here on my headphones, they're traveling in a horizontal circle. So the only force that really matters here is the tension force keeping them moving in a circle. And they are, again, going to be following a circular path, which means that our centripetal force equation does hold. So with that, let's go ahead and draw and go through our guess method. So let's start with our givens. So we know that the mass of my headphones is 5 grams, or 5 times 10 to the negative third kilograms, because remember, we always do want to be in our SI units. We know the linear speed of my headphones is 10 meters per second, and that the length of the headphone string is 0.5 meters, meaning that my radius is 0.5 meters. And that leads me to my unknown, which is the force of tension, in my string, keeping my headphones on the circular path. So my equation here is as follows. So I know from my free body diagram that my tension force is my centripetal force. Therefore, my tension force is equal to mv squared over r, which allows me to now finish off this problem by subbing and solving. So my tension force is equal to 5 times 10 to the negative third times 10 squared over 0.5. Therefore, my tension force is 1 million newtons. And there you have it. We have used the centripetal force equation to find our tension force. Let's look at a second example. A 1,000 kilogram car makes 10 laps of a track in 1 minute. If the frictional force acting on the car is 500 newtons, what is the radius of the track? So again, drawing our free body diagram, we have our frictional force keeping our car moving around our track. So our frictional force is our centripetal force. We know that the car has a mass of 1,000 kilograms, and we know that it makes 10 laps of the track in 1 minute. So omega is equal to 10 times 2 pi over 60 seconds, or, because it's a little more useful to find v a lot of the time, we know that v is equal to 10 times 2 pi times the radius of the track over our time, so over 60 seconds. So with that, and then so I know that because that's the distance that I travel. So I travel 2 pi r meters 10 times in 1 minute. So that will allow me to find my speed, and that sets me up to find my to list my givens. So I know that the mass of my car is 1,000 kilograms. I know that the force of friction, which is my centripetal force, is 500 newtons. And I know that my speed is equal to 1.05 r meters per second. And that's just plugging this into my calculator. My unknown here is r, and my equation is going to be my centripetal force equation. So I know that my centripetal force, Fc, which is my force of friction, is equal to mv squared over r. Thus, my frictional force, my frictional force, from here I'm going to go ahead and sub and solve. I should have written that first. I know that my frictional force of 500 newtons is equal to my mass of 1,000 kilograms times my speed squared, so 1.05 r quantity squared divided by r. So what that will give me is that 500 is equal to 11,002 r squared over r, and I got that by distributing my exponent out and then multiplying 1.05 squared by 1,000. So my exponents will cancel, and what I'll get about is that 500 is equal to 1,002 r, therefore r is equal to 0.45 meters. And there you have it, guys. I have solved through example 2. So really quickly before we go, let's go ahead and talk takeaways. Our most important takeaway is that centripetal force is equal to mv squared over r. And then our second takeaway is that any force can act as a centripetal force as long as it's the force making an object move along a circular path. So with that, it is your turn to try solving some problems. Best of luck and happy solving.